Hello, mathematicians. So we are still on day 8, but we're on page 17. So I'm calling this day 8A. We're going to look at that bottom question, which reads right over here, which read the roots of a function are x equals -2 and x equals 9. Write a possible quadratic function for these roots. Okay, so I really wanted to focus on this because this question does come up a lot. So we need to remember roots, okay, that the roots here are x minus 2 and x equals 9. And what they're asking us to do is to write a possible quadratic function. Okay, so here when we're thinking about it, well, the roots, other words for roots, right, are zeros. I probably spelled that wrong. X-intercepts and solutions. Right? All these words are interchangeable. What really is, that's really the result. So we've been solving quadratic functions or quadratic equations. Now, what this is really making us do is work backwards. So if I were to set something up, just to give like a little diagram, it would look something like this. Originally, we would start with our function, okay, or I'll put here equation. This would be our starting point. And then somewhere in the middle would be our factors. And then from our factors, we would get to, I'm just going to use the word roots for right now. Okay? What they're giving us here is they want us to start from the roots and really work our way up to that equation. So that's what we're going to be looking at today. So we are starting with x, I'm going to give myself some more room. X equals -2 and x equals 9. So that would be our roots. And then before our roots, we're going to get to our factors. So remember, when we get to our factors, we make that t-chart. So I just did the t-chart now. So when thinking about this, how do we go to our factors, which we know are going to be binomials? Well, when we went there, remember that we had this, everything is equal to 0. And then remembering that we had to set both of our binomials equal to 0. And then we then wanted to find what x is, so we had to isolate x. We're working backwards. So if we want to have our roots equal to 0, then we're going to, in this case on the left, we're going to add 2 to both sides. So now we have x plus 2 equals 0. And then we could say that one of the factors here is actually x plus 2. And let's do the same thing on the right. So again, we wanted to go back to be equal to 0. So here we're going to subtract 9 from both sides. Let's bring this down a little bit. And then we would have here x minus 9 equals 0. So the other factor would be x minus 9. And then eventually we want to get to our equation up here, and we know that is also going to be equal to 0. Or our function in this case. So from here now, we have our two factors. Well, in order to find our trinomial, if we're going back to unit 5, right, we have to multiply our two binomials together to get our trinomial. Okay, so there are different ways we could do when we were multiplying binomials. We could do the area model, or we can do distribution. I am going to just model the area model for right now, so I'm going to try to do it a little bit on the side. Okay, so this is a binomial, so it's going to be a 2 by 2. And I'm going to have x minus 9 and x plus 2. And inside I'm going to end up with x times x would give me x squared. And then x times negative 9 would give me negative 9x. X times 2 would give me 2x. And 2 times negative 9 would give me negative 18. And just so I'm just going to put it over here to have x squared minus 9x plus 2x minus 18, just to show the step before. Now I combine like terms, which is our negative 9x and positive 2x. Then I will end up with x squared minus 7x minus 18. And here we go. There's our trinomial. There's our quadratic function. Okay, I would, because right now this is set as an equation, I would just go back and erase the 0, and you could put y, you could put f of x, whatever you feel like you want to put there. All right, so we make sure that it represents a function. Okay, thank you.